smooth sailing, OpenGL and QML. And I thought I'd start with some sort of soothing pictures. Hopefully you guys have got some lunch and now you're sort of ready to digest this pretty interesting topic. So we do some other boats other than these power boats. We've got some fast, speedy boats, also some motorhomes, RVs, and horse floats as well. So there's quite an interesting mix of places where our devices end up. So this is that digital switching that you may have seen earlier on. I'm not going to talk much about the actual digital switching side of things. What I'm going to focus on is the user interface. So we have an existing app, which is basically the window to our digital switching. It doesn't necessarily control everything. It's not a centralized system. It's more just monitoring all the signals and displaying it for you and able to send out signals to everything else. It was based in Qt4. It's quite functional and practical. The boat builders like it, the owners like it, but it is a bit behind expectations now for a touch interface. And there's really an opportunity for us to improve the experience. So just sort of set the scene for you. We have a product owner with a vision, which is great. We're going to Qt5, QML, which is really interesting. We've got some existing hardware that I showed you just before. It's an embedded Linux platform. We've got also an existing tablet application. So we have sort of done some work already on converting it to touch interface. We're trying out agile development practices, and we're working with an external graphics design agency. That's really important. We don't actually have the luxury of walking, down the hall and asking the designer what he meant by this. So it is a bit more complicated, but it also maybe forces like the interactions a bit more. You've got these regular meetings, and they look really good. So they started with some paper mock-ups, like physically in front of you. You can circle things, you can scribble on things, and that was really good. They moved it to more digital mock-ups, and they're defining the design language that we need to be implementing. They've got colors, what colors mean what, and fonts. Actually really hard to buy a font. I don't know if everyone's ever tried that. This company just wouldn't sell me their font. I'm like, fine, I'll go with a different font. That's fine. So they also did like some interactive demos where this is the designer leading the process. They've using their tool to generate something you can click on and go through and see menus coming up. And it's nothing's working behind it, but the user interface is somewhat sort of you can navigate, and that's great because it takes time away that I don't have to spend. Gets the point across really well, but our product owner can take that and show it to his customer. So we're getting some first feedback before I've even touched the project. So that's really, really good. So then they come up with some design, and this is kind of what we settled on. It took a big process to get to here, but okay, we've got some design now, and we're going to be implementing one of the components on here, which is the sort of like the round buttons. The first thing I'll say is you really want vector formats from your designer. There are some free tools like Inkscape, which are great if you've got maybe Adobe Illustrator or Graphic. They make things really, really, really easy. So a case we had is the product owner saw this design that came back. He's like, oh, I wonder what it looks like if I have a blue heading and a black background, and I sort of was like right-click, change color. What about this? And he's like, oh, you know what? It was better how it was, but we didn't have to pay for the designer, right? So there's an external company. We don't have to do that interaction. So it's very quick to do that, which is good. You're going to want to extract the individual components. So you're never going to end up with the actual image. If the designer gives you like a rendered image, that's not going to be what you want to use. You're going to want to extract out the individual components and then eventually turn them into some code or something like that. You can automate these tools. I know Inkscape has a command line interface. Anything you can do through the UI, you can do through the command line interface, as far as I know. So those things are really, really useful. You will resize your image many, many times. So Qt5 can actually render vector images. Like if you're in QML, if you say, here's my image, it's an SVG, it really, really can just, here you go. What it's doing is it's creating the image first. So it renders internally to an image, and then it displays the image. So there's inherently more time involved in doing that. So our first implementation was a vector graphic. So we had this vector file from the designer, so I'm going to put it on my display. And And the reason I wanted that is I want some feedback on the colors. You know, our designer's got his brilliant, I don't know how many pixel color definition screen in his lovely lit studio. You know, the colors are going to look different on a boat with sunlight on it. You know, so we get that feedback really quickly. I still haven't done any code. I've just put the vector file on the display. You get a lot of sort of feedback on size and positioning, and gradients is a good one. You know, if you have maybe a less than ideal LCD screen, gradients may not look the way you think they're going to look, and it avoids this time-consuming image manipulation, right? So you just put this vector there; it's resized to the correct size. You haven't gone and done any sort of image manipulation first, but it is slow to render, so you can't. It's maybe not practical for all of your final design, and it's a static image. I mean, we want some animations here. So, like for example, this button, that ring is supposed to go and represent the value of that circuit. So, you know, how, if it's a lighting, you know, is it sort of how bright is that light, or is it a pump? How fast is that pump going? So it was actually giving us some feedback, and we can't do that easily with the vector file. Well, actually, before I do that, I'll just show you quickly what this is going to do. If this all works. Let's hope so. Right, so this is the UI now running on my machine, and we've got this is that same UI implemented. You've got some interesting things. Maybe we've got some alarms here. You can see the red one, and this is that button sort of, you know, charging up. When you turn on your lights, they're going to fade on, so the displays also kind of fade on, and it's all really, you know, quite visually appealing, especially when they all fade on at once. It's quite cool. So this is what we're going to end up with, hopefully. Actually, I know the answer to that, but don't want to spoil it. So what we did then, number 2, is shaders. Is anyone familiar with shaders? If I say shaded, does that mean cool? All right, good. So what you need to know is in QML itself, you can create this thing called a shader. And it allows you to create some more dynamic content. You can create some animations or some color changes, and you can get this feedback from the product owner really quickly. You can still use your QML to drive any animations or anything that you had before, and I'll show you how that works. One of the bad things is it's not so great for creating geometry, and I'll show you why that is in a minute. So what these shaders are is on your graphics card, there are various places where you can add your own bit of software. So there's 2 main shaders I'm going to talk about. One of them, which is the vertex shader, that's the only non-optional shader. So every program has to have a vertex shader. This is taking, you know, basically for every vertex, run a program on the GPU and return a translated vertex. We've got fragment shaders, which is for every output fragment, which is kind of ends up being the 2-dimensional screen part, run a program and return a color. So we're kind of manipulating the shape and the color of objects in OpenGL. So that works. This is what it looks like. Visually, we've got triangles. Graphics cards love triangles. These would be your vertices, and then this face of the triangle would be eventually your fragment, which you would manipulate with the fragment shader. So there's a really good resource, which is the QML book, which is an open source guide for one of the chapters is shaders in QML. So you can see there, if any of you are familiar with QML, there's this fragment shader bit, and it's actually a string. So you've just got this giant string there, and it's a bit of code that looks maybe like C or something like that. That code is at runtime given to your driver to compile and then given to the graphics card. So it's quite amazing that in a runtime interpreted JavaScript, you can give it some string that then at runtime gets compiled into some code and then gets run on your graphics card. So it's all quite an awesome process, and that you can just do it in a string like that in your QML is really, really useful. So here's my naive fragment shader, and I don't expect you to look at the code. What I'll do is kind of walk through it with a bit of sort of like a visual guide here. We want to make this animation, remember, so we want to start out with a circle. What we're going to do is saying, for every color, so it's literally going through every pixel, every color that's outside the circle, we'll just make that, you know, black, and every color that's inside the circle will make that, you know, this teal color. So you can do that by just kind of trying to find the, you know, the distance from the middle, let's say, right? If the distance from the middle is greater than your radius, let's make it blank. And that works actually pretty well. And then we want this pi segment part. So we're saying, oh, well, we're going to set we're going to calculate the angle now from every of these pixels. What's the angle to the middle? If that's greater than our input value, then we'll make it black, and if it's less, then we'll make it teal. And then finally, we kind of add our button image that's just on top, and it's got a transparent ring, and then we can sort of see that pie graph underneath. And this is great. This works really well on my machine. I can show it to the product owner. He says, this is great. I love this effect. But I put it on my display, and it actually runs really, really poorly. The reason is this bit here. And I don't even know much about the details of these shaders, but it's not a traditional program. It's not behaving in the way you'd expect it to. You can do these things, but at a huge penalty cost. Like a conditional statement is really, really bad in a parallel processing environment. But it still works. And actually, the product owner, he said, one of the effects I'd done, he said, oh, I don't like this at all. And I was like, oh, that's fine. I haven't actually spent much effort on it. If I'd gone and implemented the whole thing, he's like, oh, this is rubbish. I'd be it's like, oh, really? Are you sure? What can I do to change your mind? But he doesn't like the effect. He's like, fine, let's take it out. What do you want? He's like, oh, actually, the fading on is what we want. Great. So now we had this poor performance, and this profiling is what I wish I'd done from the start. There's a few things you can do. You can do an FPS counter. You can sort of count how many times your frame's being updated. In QML, there's all sorts of logging you can enable. And inside the Qt creator, there's a QML profiler. So it'll break down the render thread and tell you how much time it's spending in every part of your process. So I'll show you a quick demo of our simple shader. This is converting. This is basically that first example I showed you with where we were modifying the red. But what we really want to see is that complex shader with the pie graph. So here you can see on the left, it's basically without the image, and on the right, you've got that button. So my QML input is driving a value that's getting passed to my graphics card to update this pie graph. And it actually works surprisingly well. When you first do this, you're like, oh, I'm onto something. This is great. I've got this new tool. But creating geometry in a fragment shader is about the worst thing to do. And why is that? Is because the rest of your graphics card is designed to do geometry. I was just working on the color output bit, but what about the actual geometry part? So implementation number 3 was QPainter. So Qt has some geometry drawing capabilities. So I mocked up a C++ class that ends up in QML that I can draw this pie in. It's great because it's got a simple API. I can see it work. I can update the value, but it was actually still quite slow. And here I think it's because it's drawing this amazingly nice pie for me. I didn't actually need such a nice circle edge, right? It's probably spending a lot of time making sure that angle is just right, and it's sampling the image, and it's doing all sorts of nice things that you'd normally want if you were drawing a pie. But we're not actually drawing a pie, we're drawing this button. So I also have a quick demo of that. So it is actually, this is now being driven from a QML some time animation. And you can see on my PC it's fine. On our display, it's still a bit slow. I just sort of thought I'd like to mention animated sprites. There is the capability in QML to do an animated sprite. That's where you have an image that is lots of tiles of other little images. And it kind of plays them in sequence. And the cool thing is that's stored on your graphics card. It creates a single texture for the whole thing, and then it sequences them itself. So it can be actually really fast. This has really good performance, but it is quite limiting in what you can do with the animation. If you're doing a little spinny circle animation, that might be ideal. You might have maybe half a dozen frames. But if you're trying to do a complex, pie thing that has lots of different stopping points, and you want to have one when it's red and one when it's blue, and maybe you want the user to be able to input their own color into this, So it was interesting, but our final implementation was a custom OpenGL Framebuffer. So our GPU loves triangles, so let's give it triangles. You can draw this pie by simply adding triangles around in a fan, and it even has a fan triangle function, right? This is what it's for. We can still use color as a fragment shader, so we can still add our color from QML and have our alarms and things. They're all nicely done, but the pie part of it, that's done now like it should be. We can still control the blending and things, so we can add that image on top in OpenGL as a texture, and we can render that to a Framebuffer object, which in QML ends up on your page, but it only gets updated if the values change. So if you update your Framebuffer, then it gets re-rendered, but if it's sitting there doing nothing, it's just actually an image, in your memory of graphics card. So things like swiping and big screen works really, really well, because it's not drawing all those triangles every time. It's only drawing them when you want that animation. So that was what we ended up going with. So you can see now we've got this color coming from our fragment shader. We're using QML's easing to create like a nice sinusoidal thing, and it's all I've done really is implemented the rendering part of it. All the rest is still done in QML. I haven't had to do any extra work. I can show my product owner, and he's like, "Oh, I hate this blending. This color. Let's take that out." It's fine. I don't mind at all. The thing that I was working on is actually getting that bit that he did really like working really well. So as I mentioned, it creates a 2D texture, only rendered when updated. If you want to look at, there's a really good example in the Qt example pack. So scene graph rendering FBOs, that one's quite good. Basically does exactly what I've just done. Be aware of the rendering threads. So if you update your Framebuffer object, it has to be done on the render thread, which is separate from your normal UI thread. And there's some really good pages and documentation in the Qt documentation for that. And also be aware that your OpenGL context is shared, so there might be some sort of gotchas there if you're doing something that it didn't quite expect. So you sort of leftover context from another OpenGL action sort of might carry over into your part, so you might have to make sure everything's set up correctly. And it's easy to expose this Framebuffer object to QML with this QQuick Framebuffer object class. So if you look up that example, it'll show you how to do that. So I think I have some code slides just for fun, show you like what actually ended up being drawing that triangle. So this is basically creating the vertices. It's a bit of mathematics, not too tricky. You can look up, oh yep, I need to create a bunch of vertices in a circle. And then you need to render them out, so you have a render function. And so you can see that GL draw arrays is my OpenGL call. And it actually has a triangle fan drawing method, which is all I need to specify the vertices around the edge, and it will make it a fan-based primitive. And the way I'm controlling the percentage is basically all of that. You've got like about 100 triangles loaded into memory already, but you only draw the ones you want to draw. So if you're at about 45%, you draw 45 triangles. And if you're at 100%, you draw all 100 triangles. But 100's nothing for the GPU. It loves the stuff. It eats triangles for breakfast. So your final usage looks something like this, where you've got a nice QML component. You're passing a color. You're passing a value. And those can be bound values. You can animate them. You can do whatever you like. And it all just works really, really nicely. And don't tell the designer I did that with his icon. I don't think he'd be very happy. So that's all I've got.
Thank you very much, Jeremy. We're running just a little bit short on time, but we can probably take a question or two before we have to wrap up and get you folks on to the next session. Any quick questions for Jeremy?
Yeah, a couple quick ones. I assume these same capabilities are available in traditional Qt widgets. You don't have to use QML. And also, can you get QSS styling in the QML domain?
So definitely the OpenGL is certainly available from your regular Qt widgets, but not through the method I was using with that QQuick Framebuffer. I know you can create Framebuffer objects, I think, and then use them in regular Qt widgets, but I'm not sure how that ties in. I mean, I was kind of tied into QML because I was working with their render thread, and it had to be done in that way. So the OpenGL part, which you can keep quite separate, where it actually comes down to draw the pie graph, that can be reused, and then kind of like a wrapper, that QQuick Framebuffer wrapper would be separate. And as opposed to the styling, I don't know. I don't know actually. Maybe I haven't tried that.
Okay. Anything else?
Hi. How is it to write a programming snippet inside another one? It seems a little bit like HTML and JavaScript like 20 years ago. Do you get help from the editors?
Yes, so some of my, like Sublime Text just doesn't like it at all. It thinks it's something else and doesn't conform to the style to have a multi-line comment. But a multi-line string is valid in the QML syntax. So it is a bit weird. There are better ways to separate your shaders out. You can write them as separate resources and put them in your resource file. That's the way to do it.
Okay, that's all the time that we have. Thank you very much, Jeremy Stott from BEP Marine.
Thank you.